So welcome everybody to this latest video on 162 Maths, and in this video we'll be continuing with quadratics with a focus on problem solving. Now this particular topic is high level GCSE or AS level and does require some prior knowledge of factorising and solving quadratics using the quadratic formula. So if you're not too aware on that, then I strongly recommend you watch the video on that particular topic. Now there will be a copy of the questions that I go through in the examples in the description below for you to download and either work with me or work after watching this video. Now once you've mastered being able to solve quadratic equations using different methods, so factorising, completing the square, using the formula, there may be problems where you need to first form a quadratic equation before going on to solve it. Now often these problem solving questions are hard to spot and they are related to quadratics until you reach a certain point of the problem. These questions will often start with knowledge of another topic in maths, so for example area, units, graphs, etc. Now these problem solving questions are often worth a lot of marks, like 4, 5, 6 marks, so it's really important that you show detailed step-by-step working out. Now generally you want to emphasize the following 3 points. So the first one is the creation of the equation. Now when it's a quadratic, or when you sense that the equation is becoming a quadratic, you want to end it by making it equal to 0, which is the fundamental part when you go on to solve an equation, which kind of leads us into the second part, which is solving the equation. Now if it's quadratic, you'll do this by either factorising or using the formula. And then with step 3, you'll obviously, if it's a quadratic, you'll end up with 2 solutions, so you want to make sure that you're picking one of the correct of those 2 solutions. Now the answer will not be both answers, though it is really important that you do still show that there are 2 answers, whether one be completely oblivious to let's say if it's a really big number or a really small number, it's not really applicable. But you always want to make sure that you are still writing those 2 values. And then for your final answer, you want to make sure that you are picking the correct value. Now often these problem solving quadratic questions relate to area, which will lead on to some examples. And so if you have, let's say, an x value and one of them is negative, well, if you substitute it back into the actual diagram or the area, you'll find that you'll end up with a negative length, which you obviously cannot have. So you'll lose marks if you just state those 2 values. You always want to make sure that you emphasize and also write down, okay, x equals this, because it can't equal this, because obviously you'll end up with negative length. So it's really important that you do add detail, and if they're offering you 5 or 6 marks, then you really can't complain if they're asking you to do that, go that extra step. So let's have a look at this first example. Now this example is very popular when it comes to exams, and I would say it's usually worth about 5 or 6 marks depending on what stage they want you to stop at. So in this question it says that a box is made from a piece of rectangular card with sides x and x plus 6 centimeters. A 2 centimeter square is cut from each corner and the sides are folded up to form an open box. The volume of the box is 100 centimeter cubed. Now looking at this net of this particular shape, now if I just quickly draw, and again excuse the drawing of this, then what this box will kind of look like is it looks something like this, where the box is open and you've got something that looks like this. Now in terms of this, now to work out the volume, obviously we've got this length here, we need this length here, and we need this length here. Now the first thing we need to do is find out the dimensions of this particular box. So we need to know what these 3 different lengths are going to be. Obviously it's the volume of a cuboid, so that's what we're needing. Now looking at this box, what we need to do is establish what these sides here are. So from this, if all of this length is x plus 6, this length here is 2, and this length here is 2, then this length here is going to be x plus 6 minus 2 minus 2, because I'm taking away these 2 little lengths here. And that gives me a total. If I simplify this, this gives me x plus 2. So this length here is x plus 2. Then looking at this length here, just highlight it in blue, which is the next step that I need to look at. Well again, this length here is 2 and this length here is 2, so this is going to be x, which is all the length, take away 2, which gives me x minus 4. So this length here is going to be x minus 4. Now the height of that box is going to be 2 centimeters. So what I'm going to do is I'm just going to label this as this is 2, and that's going to be what that is. So let's just get rid of that a little bit neater. and that is going to be 2. Now from that, what we now need to do is we've now got the dimensions. Now in terms of working out and writing this down, that would be enough. As long as they can see in your exam that you've got these 3 lengths, then I would say that's probably going to get you maybe 1 or even 2 marks because you've got the 3 dimensions. So looking at this, we know that the volume of this box, I'm going to use these algebraic terms, and I'm not going to worry about the units, I'll bring that in later. So the volume is going to be x plus 2 multiplied by x minus 4 multiplied by 2. Now if I just write that using proper algebra, it's going to be x plus 2, x minus 4. Now if I expand that all out, what I get is I'm going to leave the 2 for now, and I get x squared minus 2x minus 8, and if I then multiply everything by 2, I get 2x squared minus 4x minus 16. Now it tells me in the question that the volume, now that would probably get me, I want to see that's the volume. So this here is the expression that represents the volume. Now sometimes in a question they may just ask you to show that the volume of the box is this expression. This question is actually asking me to go on to find out what x actually is. Now it tells me that the volume is equal to 100 centimeter cubed. So this, I've got to make this formula equal to 100. So I've got x squared minus 4x minus 16 equals 100. Now this is now slowly starting to look like a quadratic, so what I need to do is make this equal to 0. Here I've got x squared minus 4x minus 116, and that equals 0. Now again, this is where we've now got our quadratic. And there is a difference between what I've highlighted in yellow and what I've highlighted in pink. This is incorporating that they've told me that the volume is 100 centimeters. What's in yellow is just the volume expression. So because they've told me that the volume x is going to be a particular value, so that's why I need to show that this here is the actual expression of the volume of this particular bit of this box, given b equals 100 centimeter cubed. So what I now need to do is solve this equation. So when I'm solving this equation, I've got 1 or 2 options. I can either try and factorize, or I can try and use the formula. Now, for argument's sake, I'm going to go straight into using the formula only because it's quicker, and also looking at the numbers, we can see where we go from there. Now, it may be possible to factorize this, so let me just quickly have a look to see if it does. In which you can spend, now obviously if I just get rid of all of this, and let me just make sure that I'm making note of the equation. So before I get rid of all of this, now obviously in a real exam you do not want to be rubbing anything out, because obviously this is all going to give you marks. Like so. And let's just have a look to see if this does simplify, does factorize rather. Now with this particular equation here, this does not actually factorize. So what I'm going to do is I'm going to use the quadratic formula. So what I'm going to do is I'm going to state my value of a, which is 2, b equals minus 4, and c equals minus 116. So using the quadratic formula, which again is minus b plus minus square root of b squared minus 4ac, all divided by 2a. And that formula is not given to you, it's something you're going to need to remember. So substituting the values in, I get positive 4 plus minus minus 4 squared minus 4 lots of 2 times minus 116, all square rooted, divided by 2 times 2. Let me just put the 2 minuses there so you can see the clear substitution. And if I type that into my calculator, I get my 2 answers being, let me just quickly do just that. I get 1 plus root 59. Well, you don't want to leave it in surd form, so you actually want to write it as a decimal, and that's 6.6811, blah blah blah. Now the second value is 1 minus root 59, which is minus 6.6811, blah blah blah. So these are my two solutions. Now what I want to do is only one of them is going to be valid. Now because obviously the length of this is going to be x and x minus 6, it can't be this value here. So x, so this value would give negative length. Now don't think that it's always going to be the positive answer, because in some cases it might be the negative answer that's the valid answer. So always just make sure you understand what it is you're actually looking at. So this value would give negative length. So x equals 8.68 centimeters to 2 decimal places. 2dp, and there is my final answer. So again, a lot of work, but again, you expect to use 6 marks, so you're looking at 6 minutes to be able to do, but it's important that you do state those values. And like I said, make sure that you are stating the two values. Don't just give one and just interpret, especially if you're using your calculator, think, all right, it's only going to be the positive answer. Again, just make sure you're substituting it back into whatever length you're looking at to make sure you're picking the right x value, the right solution. So let's have a look at our second example. So here it says that a rectangle has a perimeter of 25.42 centimeters. The width of the rectangle is x and the length of the rectangle is x squared. And the question is asking us to find the width of the rectangle. So what we're actually basically asking us to do is find x. So looking at this, to work out the perimeter, which again is not to get confused with the area. So the perimeter, so P equals x squared plus x squared plus x, which gives me 2x squared plus 2x. Now it tells me that this perimeter is equal to 25.42. So there what we've got is we've got 2x squared plus 2x equals 25.42. Now again, this is now where it starts to look like a quadratic, so what I need to do is take that over to the side to make it equal to 0. So I've got 2x squared plus 2x minus 25.42 equals 0. And that there is my equation that represents the perimeter of this rectangle. Now because we've got a decimal constant, I'm going to go straight into using the formula. There's no point me trying to factorize this, I'm just going to go straight into it. So using the formula, so I've got a equals 2, b equals positive 2, and c equals a rather awkward minus 25.42. So substituting in the formula, I'm just going to just do that. So I've got minus 2 plus minus square root of 2 squared minus 4 times 2 times minus 25.42. Now the more awkward the numbers, the higher the level, the grade of the question. So if you're looking at a grade 8 or grade 9, then expect to have some awkward numbers. And that's going to be divided by 2 times 2. Now if I type that all into my calculator, let's have a look at what I get. 2 and minus 25.42. I get a solution of 3.1 or minus 4.1. So these are my two solutions. Now in terms of this, which one looks more realistic? Well, because x is the width of that, it can't be this. So it cannot be this, as it give a negative length. Now sometimes in the question they would ask you to first generate the quadratic expression. Part B would then be to solve it, which is these two answers. And then part C then may say, well then find the value of x. So here part B is asking you to find the two solutions. Part C is then stating which one it is. And they may ask you for a reason in which this would be your reason. So then the value of x equals 3.1 centimeters, and that there is your final answer. And it's definitely worth emphasizing the answer. Do not leave your answers underlined like I've done here. You want to emphasize that x equals which of the two values it can be. So let's have a look at this next question. So it says that a rectangle has length of x plus 5 centimeters and a width of x minus 1. A corner is removed from the rectangle as shown, and the area of the shaded section is 59 centimeters squared. and the question is asking me to find the value of x. Now with any shaded area, it's always the big shape minus the small shape. So here my big shape is the rectangle and the small shape is the triangle. So what I need to do is I need to find expressions for these two things. Now in terms of the rectangle, well that's going to be x plus 5 times x minus 1. So that's x plus 5 x minus 1, because obviously it's length times width or height times length, whichever floats your boat. So then expanding this out, we get x squared plus 4x minus 5. We'll box around that, so that's a rectangle. Now for the triangle, well that's base times height divided by 2, so base times height divided by 2, and that's going to be 4 times 3 divided by 2, which equals 6. So that means that the shaded area is going to be equal to x squared plus 4x minus 5 minus area of the triangle, which is 6, which gives me a total area, just simplifying that, of minus 11. There is my expression for the shaded area. Now it then tells me that the shaded area is 59, so what I've got to do now is make this equal to, so as shaded area equals 59, that means that x squared plus 4x minus 11 equals 59. But what I now want to do is make that into a quadratic by making it equal to 0. So I've got x squared plus 4x minus, and it's going to be 70 equals 0. So now what I need to do is now solve this quadratic equation. So what I've got, and again I'm going to go straight into using the formula. So I've got a equals 1, b equals 4, and c equals minus 70. So substituting this all into the formula, I get minus 4 plus minus the square root of 4 squared minus 4 times 1 times minus 70, all divided by 2 times 1. And again, you can I'd definitely simplify that. If you're not sure, definitely watch the video on using the quadratic formula. So here I've got 1, and just typing it into your calculator and seeing what you get, and I get solutions of 6.60, or I get minus 10.60. So these are my two solutions. So which one looks valid? Well, again, if I substitute this value, or this minus 10.6 into x plus 5, I'm going to end up with a negative length. I'll also get a negative length if I substitute this value into this. So it definitely can't be this one. So it cannot be negative length. So then my actual answer is going to be x equals 6.60, and that's to 2 decimal places, and that's also in centimeters, and there is my final answer. So let's have a look at this next question then. So with this next question, it says that a trapezium has parallel sides of x plus 1 and x plus 2. The perpendicular distance between the parallel sides is x. The area of the trapezium is 15 centimeters squared. So the key thing I need to look at here is the area of a trapezium is a plus b times h divided by 2. So this here is my a, this here is my b, and the perpendicular distance, which is basically the height, just up there, is h, and that's going to be h. So the area of this is going to be x plus 1 plus x plus 2 multiplied by x, all divided by 2. Now simplifying this, I get 2x plus 3 times x divided by 2, and simplifying that further, I get 2x squared plus 3x, all divided by 2. Now it then says that the area is equal to 15, so that then equals 15. So what I need to do is now solve this. I need to make it look like a quadratic, and to make it look like a quadratic I need to make it equal to 0. So the first thing I'm going to do with this is I've got 2x squared plus 3x over 2 equals 15. Well, I'm going to take the 2 over. What I get is 2x squared plus 3x equals 30, and then take the 30 over to the side, so I get 2x squared plus 3x minus 30 equals 0. And there you go. Now you might want to think to yourself, can I simplify that by dividing both sides by a number to make it x squared? That's entirely up to you, but with this we can't because we've got coefficients of 2, 3 and minus 13. There isn't a common factor that goes into each of those three numbers, and I definitely don't want to be messing with decimals. So what I now need to do is solve this. And again, I'm going to go back to the trusted formula. So we just highlight this formula here, and that's what I want to go on to solve. So here I've got a equals 2, b equals 3 and c equals minus 30. So substituting this into the formula, get minus 3 plus minus 3 squared minus 4 times 2 times minus 30, all divided by 2 times 2. Square root goes all over that. Now if I then go on to type this all into my calculator, let's have a look at what answer I get. And let me just do just that. Well, I get an answer of 3.19, or I get minus 4.69, and they're to 2 decimal places. So these are my two solutions. Now again, because x is the height, I can't end up with a negative length, so this is not the answer. So not, so NA, as it would give negative length. So here x equals 3.19 centimeters, and that's been rounded to 2 decimal places. So there is my final answer. So let's have a look at this next example, which looks a little bit more complicated, but this is a complicated topic and it's quite highly advanced. So it says the diagram below shows a six-sided shape. All corners are right angle. All measurements are given in centimeters, and it says that the area of the shape is 25 centimeters squared. Now, in terms of this, let's just have a look. Now, I'm going to go, now to work out the area of this, I need to break this shape up, and you can see how I've been given the 2 dimensions of both of those two shapes. Now, let's just say, for example, let's say I didn't know what those solutions were, what the lengths were. Let's say I need to know what this length here is. Well, this length, well, if all of this is 2x plus 5, I'm going to take away this length here. So that's going to be minus 3x minus 2. So that's going to give me a length of minus x plus 3. And looking at this length here, if I get a different colour, let's go for green. This length here, well, that's going to be 3x minus 2 plus 2, which is just 3x. So there I've got all my sides of this particular, what I've done there, let me just get rid of that. Pencil. So here I've got all of those 6 sides are now labelled. And so, however, I'm not going to use those, so let me just quickly get rid of it. But that's basically how you would work those out. So working out the area of this blue shape, I'm just going to label this A. So area of A is going to be 3x minus 2 times 2x plus 5. And if I expand the brackets out, I get 6x squared plus 15x minus 4x minus 10, and simplifying that, get 6x squared plus 11x minus 10. And then looking at this little square here, which I'm going to label B, and that's going to be 2 lots of 3x minus 2, so that's going to be 6x minus 4. So the total area is going to be where I add these two expressions up. What I'm going to do is add them up. So I've got 6x squared plus 11x minus 10 plus 6x minus 4. Now collecting like terms, well, I've got 6x squared plus 17x minus 14, and that's what the expression is going to be. Now it tells me that the area of this shape is 25, so I need to make this equal to 25, and I'm going to take the 25 over. So what I've got is I've got 6x squared plus 17x minus 39 equals 0. Now this is what I now need to go on to solve. So again, I'm going to go straight into the quadratic formula. I've got a equals 6, b equals 17, and c equals minus 39. So type this in, I've got minus 17 plus minus square root of 17 squared minus 4 times 6 times minus 39. Again, not the nicest of numbers at all, but you have got a calculator to assist you with this. So typing in all of those numbers, 6 minus 39, and I get an answer of 1.5 or minus 4.33 recurring. Now this in fact does actually factorize. Again, if you're good at factorizing, you could go for those two answers. So again, it's asking work out the length of the longest side. Now looking at this, it's definitely not going to be this value, so it can't be 4.3, so that one's not applicable. So x has got to equal 1.5. Now the question's not asked me to find out x, it's actually asked me to find the longest side of the shape, and the longest side is this. So if x equals 1.5, then 2x plus 5 is going to equal 2 lots of 1.5 plus 5, which equals 8. So it's 8 centimeters, and there is my final answer. Now again, you want to try and work down in steps. Obviously mine's a bit of a mess because it's all over the shop, but that's only because I want it all fit on the screen. So let's have a look at this next question then, which I think is, oh no, it's the second to last one. So it says here that a picture of 8 centimeters by 3 centimeters had a border of x wide round it. The area of the border is equal to the area of the picture. So let's have a look. So looking at this then, so the area of the picture is going to be 8 times 3, which is 24 centimeters squared. So the area of the border is also going to be 24 centimeters squared, which is going to be important. Now the question is asking me to find out x. So to work out the area of the border, well, that's going to be what this length, well, to work out that, the area of the border is going to be the area of big rectangle minus the area of small rectangle. Now, in terms of this, let me just add this in. So this length here has got two x's. There's one x there and one x there. So this is going to be x plus, 2x plus 3. And this length here is going to be 8. And then I've got to add two x's there. That's going to be 8 plus 2x, or 2x plus 8. So the area of the border is going to be, the area of the big rectangle is going to be 2x plus 3 times 2x plus 8. And again, if I expand the brackets out, I get 4x squared plus 16x plus 6x plus 24, which gives me 4x squared plus 22x plus 24. And the area of the small rectangle is going to be 24 because I've already worked that out. So the area of the border is going to be 4x squared plus 22x plus 24 minus 24. And simplifying all of this gives me 4x squared plus 22x. Now it tells me that the area of the border is 24, so all I need to now do is solve this. And that's equal to 24. And so by making that, then minus 24, and that's now equal to 0. So what I want to solve is 4x squared plus 22x minus 24 equals 0. Now to save us looking at big numbers, what I could do is divide both sides by 2, so that gives me 2x plus 11x plus minus 12 equals 0. So now I'm just dealing with small numbers. However, it doesn't really make a difference to the final answer, so as long as you're using those coefficients or you're using these coefficients, you should get the same answer when substituting it into the quadratic formula. So I'm going to use, let's just use the original. So I've got a equals 4, b equals 22, and c equals minus 24. So typing this in, I get minus 22 plus minus 22 squared minus 4 times 4 times minus 24, all divided by 2 times 4. And you can see I'm using really big numbers. So again, another option would be to use a equals 2, b equals 11, and c equals minus 12. Again, it should give you the exact same answer. Let me just quickly type that all in which I get an answer of 0.93, or I get minus 6.43, and they're to 2 decimal places. Now x can't be negative length, so this one, NA, so x equals 0.93 centimeters, and that's to 2 decimal places, and there is my final answer. And again, just make sure that you do state both answers or solutions to the quadratic, but that you're only giving one answer to this actual question. So let's have a look at our last question. So it says the diagram shows a closed rectangular box with dimensions whose dimensions are in centimeters. The area of the material used to make the box is 146. Now this area refers to the surface area. So what I need to do is I need to work out the surface area of this box. Now this box has three different sides, but I've got two of each. So I've got this yellow side, I've got this lilac side, just excuse my colouring, and I've got this little pink side here. And what I need to do is I need to work out the area of each of those three colours, times it by 2, and add them all together, and that will give me the surface area. So let's work out what each of these respective areas is going to be. Well, this length here is going to be, well, the best way of doing it is to actually label these. So let me just colour that in again. And let me just label that A. So A is going to be equal to y lots of y minus 1. So that's going to be y squared minus y. Now looking at B, which is this here. So B is going to be equal to y times 4y, which is 4y squared. And let me just label this as C. And C is going to be equal to 4y times y minus 1. So just multiplying the dimensions. That's going to be giving me 4y squared minus 4y. Now with these I've got 2 of each, so the surface area equals 2 lots of A plus 2 lots of B plus 2 lots of C. So looking at this, I've got 2 lots of y squared minus y plus 2 lots of 4y squared plus 2 lots of 4y squared minus minus 4y. So expanding all the brackets out, I get 2y squared minus 2y plus 8y squared plus 8y squared minus 8y. Now what I now need to do is simplify all of this expression. So I've got, and let me choose different colours. So here I've got 2 plus 8, which is 10, plus another 8, which is 18y squared. And that's going to be minus 10y. Now that's the expression for the surface area. Now I know that the surface area is equal to 146, so I've got 18y squared minus 10y equals 146. Now again, so this looks like quadratic, so I want to make it equal to 0, so I've got 18y squared minus 10y minus 146 equals 0. Now because all the coefficients are an even number, I can divide all the numbers by 2. So I get 9y squared minus 5y equals, and it's going to be minus 73 equals 0. It just makes the numbers a lot easier rather than dealing with 18, 10 and 146. Looking at this, I get A equals 9, B equals minus 5, and just be careful that B is minus and C is minus 73. So type this into the calculator or to substitute it in, I get minus 5 plus minus the square root of minus 5 squared minus 4 times 9 times minus 73. That's 4 square rooted divided by 2 times 9. Now again, if I type that all into my calculator and hope that I've not made a mistake, because that's definitely not something I want to do, minus 73, and we get an answer of x equals 3.14 or minus 2.58, and they're all to 2 decimal places. Now because y is one of the lengths, actually I shouldn't use x, it should be y. Don't think they'd mark you down for that, but okay, it's always worth using the same letters. So this is not applicable because it gives negative length. Can't have. So then the actual answer is going to be 3.14. So y equals 3.14 to 2 decimal places, and that's centimeters. And there is my final answer. Now we'll put a copy of these questions and some more questions like this in the description below for you to practice along with their answers to check that you are getting these right.